Thanks for that. Hey, excuse me. Ollie.
Hello.
Morning, everybody.
Good morning.
Okay. So yesterday we watched a video in class all about decision making and operations resource system analysis, and I did not know that the guy in there was under your command. I did not know that.
Yeah, he's one of my soldiers.
There you go. So, Patchogue, Medford, back in the late 1980s, on Matsonay Drive lived Colonel LaRock, and he went to Saxton, he went to Patchogue Medford High School. He's had obviously an illustrious career in the military. He's here to tell you a little bit about how you can use math, how math relates to your life, and what goes on with it. I know, John, you said, who was it that knows Colonel LaRock?
My dad's older brother might have known him, I'm not sure.
And what was his name?
Andrew.
Andrew Werner?
Yeah.
Yeah, he lived like diagonal from me. Yeah,
All right.
that's great.
So he'll walk you through a couple of problems and give you a greater and deeper understanding of mathematics. So without any further ado, let's rock.
Oh, I'll be good, Joe.
An applause. I didn't get it.
Wait, this group, you know what this group does? Wait, you know what this group does for the first time
But
in 32 years of teaching? They thanked me on the way out.
no way.
Yes, I have
Oh.
never had that before, ever.
Oh yeah, Mr. Lindquist, thank you.
Happy birthday!
Happy birthday, Mr. Lindquist.
All right, let's go.
You have a question?
Are you here for the nuclear bomb that we're building under the basement?
Oh my god.
I did not know about that
Oh,
nuclear
okay,
bomb.
just forget that.
Does the government know about that nuclear bomb?
We're not sure, Mr. Lindquist is in charge of the whole thing.
Well, I'm gonna make a phone call right after this, make sure. Okay, no, I'm not here for the nuclear bomb, sorry.
Sorry.
Okay, so, you know, I first of all, I'm very happy to be here. This is exciting for me because I sat where you sat, just a different junior high, but still in that position. And it's like, you know, I tell people, you know, I didn't start out being good at math. I didn't start out being a good student. I kind of grew into it. And we were just talking, about the time I hit 8th grade is when I really started showing that, wow, I could really do this academic stuff. But really, you know, when I look back and, you know, one thing I didn't say is when I was in elementary school, they used to test me because they thought I had a learning disability.
Oh,
Yeah, but it was because I was bored and I would daydream in class and I would never do my homework. So then as we, you know, went up, all of a sudden in 8th grade, I started doing homework and guess what happened? I started getting good grades. And so for me in junior high, a lot of things happen in junior high. You know, this is a real critical year for you guys. Believe it or not, your experiences in junior high and then high school really will affect you the rest of your life. I mean, they really define who you are the rest of your life, because they do stick with you. A lot of the lessons I learned for life, I learned, you know, about this age. You know, so it's kind of funny, you know, that those things really stick with you. So, you know, I became a pretty good wrestler. You know, I wish I could have been better. I never beat Jamie St. John, the state champion.
A lot of people can say that, though.
Yes. Yeah, he was really good. But, you know, and same thing with math. You know, I got really good in math, really good in wrestling, and this man was part of both those things for me. So that's why it's exciting for me to come back here and do this. Because, you know, it's, like I said, that was a defining point in my life. But I wasn't always good at it. So what I like to tell people is, you know, some people think that you have to have a certain, you have to be born with a certain gene to be good at math. That's what a lot of people think. And I tell them, no. It's like any sports team or anything, you have to practice, right? Practice, practice, practice. And math is no different. Practice, practice, practice. I got good at math because I found it fun. I found I like doing puzzles, you know, solving puzzles. So I viewed it as enjoyable. So every night I did math homework, and sometimes that's the only homework I did was math. You know, so math I tended to do well. But I was a late bloomer, so I wasn't in the accelerated math classes all through growing up, and then senior year came around, and I had just finished the Regents. Do they still call it that?
Yep.
Regents? Okay, still finished the Regents course, and then the next year I was going to take pre-calculus, and then this man told me, "Don't do that. Take calculus." And I kind of freaked out because I was like, "Well, I haven't taken pre-calc. How can I take calculus?" And he said to trust him, so I did. And I took calculus in my senior year, the AP calculus, you know. So that's when you take the test, and if you do well, you can skip calculus in college. So I took that course, and the first day of that class, I was sitting in class, and I was looking around, and And I said, wow, these are all the smart kids. So,
That's how I walk into school.
yeah, well, so I thought, wow, I don't belong in this class. And then the teacher said, hey, is anyone not taking the pre-calculus? And I was the only one to raise my hand, which made me even feel more self-conscious. So then I was like, uh-oh. So afterwards, I went up to him after class, and he said, look, you know, I really recommend that you drop this course and take the pre-calc, because this course is very difficult and you're gonna have a hard time. As soon as he said that, what do you think I did?
No. It said no.
Yeah, exactly. I was like, okay, oh, you don't think I could do it? I'll show you. And it just totally changed my whole psyche when someone told me I couldn't do something, which is kind of how you react with your parents, right?
Yeah.
It's the same thing. So that's what happened, and I took the AP Calculus, and I did better than almost all the other kids, all the
Wow.
other smart kids. And I took the AP exam, did really well, and got to skip calculus in college. So I went on, and I went ahead and I majored in applied mathematics. But one thing I'd like to share too is, you know, I got accepted to Rochester Institute of Technology in the applied mathematics program, which is where I wanted to go. But when it came time, my parents sat me down and said, sorry son, you can't go. We can't afford it. And so me, like I said, I like problem solving. And really, mathematics is not numbers. A lot of people think math is all numbers. And I will tell you, when you get into higher level mathematics, there's barely any numbers. When you do proofs, and he can tell you, he was more on the pure math side than the applied math, and he did a lot of proofs as well, but there's not a lot of numbers. But what it is math is problem solving. It's about solving your problems, everyday problems to very big problems. That's what math really is. So I just went into my problem solving mode and, you know, used those skills I learned all those years in school, and I figured out, I said, you know what, I'm gonna go to that school, and I'm gonna figure out how. So I joined the Army, because they had benefits where I would be able to go to school and be able to pay for it. And that's what I did. That's why I joined the Army. I didn't join the Army to become a soldier. I did it for money for college. It wasn't until after I joined the Army that I realized, wow, I really like this. And for me, it was more the camaraderie, the people. That's why I like the military. You know, no one wants to go to combat. You know, I would have rather not gone to combat, but you know, that's just part of the job.
Oh, how many times have you been in combat?
3 times in combat. Kosovo wasn't considered combat deployment. Kosovo was operational because it was a peacekeeping operation. So I was in Kosovo trying to keep the Albanians and the Serbians from killing each other. So, and that was a challenge because they love to kill each other. So, you know, and that's what we did. We just pretty much stood between, not literally, but you know, that's pretty much what the American forces were doing that. All of NATO. It was a NATO thing. So you had I worked with the Germans, the Swedes, you know, I've done a lot of work with other foreign countries, a lot of stuff. Great experiences, you know. Lived in Germany for 4 years, so that was great. Anyway, so back to the problem solving, right? So really math is about problem solving. And so if anyone, you know, in school ever says, well, why do we have to learn this? We're not gonna use it. And I will challenge that all the time. Because number one, you really don't know the future. So you don't know if you're gonna have to use it. If you go into business, you're gonna use math. You know, you're gonna use algebra. So if you, you know, even in the military, we use it. So you use math, but the second thing is, it's a very self-limiting statement when you say, I'll never do something. You don't know, and then you're limiting yourself mentally if you do that. And what I will say, especially at your age, don't limit your thinking. You know, you should feel like anything is possible. You are at a great age, and you'll hear old gray guys like us tell you, man, if I only knew then what I know now, but had your youth, oh man, the world would open up for me. So, you know, that's the thing I'll say is no limiting self-talk. Don't do that. And then the other thing is, you know, math is a training ground. So learning algebra, even if you never use algebra, which is highly unlikely, but if you never use algebra, the skills you learn in problem solving, you will use the rest of your life, right? So you will, throughout your life, you're gonna have to solve problems from, you know, day-to-day problems, which job to take, where to live, you know, all kinds of decisions that you have to make involve some kind of problem solving. So math is a way of training you to be a good problem solver. And then I'll tell you too, as an employer, you know, I have employees, civilian and military, that work for me. And, you know, I will tell you, the ones who really separate from the crowd, the ones I promote, are the ones who are the problem solvers. Because I have workers, they will bring me problems all day long and no solution. And it's like, look, you know, I have this whole organization to manage, I can't solve everyone's individual problems, so I need employees who can solve their problems. Or identify bigger problems and offer solutions to help me figure it out, because I got a lot on my plate. So as an employee, when I have employees who help me solve problems, then, you know, those are the ones I promote. So just keep that in mind, and that applies to any employment you go into, you know, it doesn't matter. So just keep that in mind. Math is about problem solving, it's not about numbers. It's not about numbers. And it's not about right and wrong answers either. Right now it is. In algebra, it's right or wrong, okay? Because algebra's got very strict rules, right? So there are rules for algebra that you have to stick to, right? But really, in higher level math, it's about the problem solving process. It's how you solve the problem that's important. And the example I like to use is when I taught mathematical modeling at the college level, I would ask students a question like, how many golf balls can you fit in a minivan? So now, all through high school, junior high and high school, every problem you get on a test is gonna have everything you need in that problem. Everything you need to solve that problem is in that problem. You know, and I'm sure you learned in this class, if you get word problems, you try to figure out what information you need to solve a problem, right? So, in the real world, you don't have everything you need to solve a problem. You know, you have big problems and you don't have all the information you need. So, what do you have to do when you lack the facts? Does anyone have an idea?
Find them.
Find them, yeah, that's it. But if you can't, what do?
Go get someone.
Either one. Go ahead.
You can ask the advice of others and see from their problem, see what you can do, solve your own. Just kind of look at others and see what they went right and wrong and try to correct
Right.
them.
Good, that goes along with the same thing. You try to search for that information if you can find it, right? But if you can't, what would you have to do?
You would have to make it.
You have to make it. What do you mean by that?
Like, you have to like, kind of like find them, but like also do your own share of work so you can like do it yourself, kind of.
Yeah. Okay, one more.
You have to do trial and error.
Ooh, trial and error.
That's
Trial and error is actually a problem-solving process. That works. A lot of inventors use trial and error, right? Now, the problem with trial and error is when you're dealing with billions of dollars and a lot of time, trial and error doesn't work. Like if we want to buy a new tank that's going to cost billions and billions of dollars, do we buy a tank, field it, put it out, and then figure out if it works or not, and then go back to the drawing book? No. So trial and error works in certain types. That's inventors. For inventions, they use a lot of trial and error. There's nothing wrong with that problem-solving process if you have the time and you have the money. It doesn't cost a lot, so that's a good one. But that's a problem-solving process. But in the absence of facts, what you have to do is you have to make assumptions. You know what assumptions are?
Yeah.
You probably heard that term, you know, if you
Yes.
make an assumption, you make an ass out of you and me, right?
Yeah.
Well, if you don't have facts, you have to make assumptions. Where, can I say ass?
It's too late now.
Okay.
It
Well,
was donkey.
But I've said
Yeah,
the
that's
same
right.
thing in class.
Okay.
We can do this.
Yeah, what makes you an ass is when you don't realize you're making an assumption. That's usually where people run into problems. They make assumptions that they don't even realize. So you gotta be conscious of the assumptions that you're making to be a good problem solver. But you have to make assumptions if you have no facts. And then as you go through, what you're doing is, what you guys are saying, you try to change those assumptions into facts as you go. So as information becomes available, you can turn your assumptions into facts, especially if your assumption is based on something in the future happening. So then when that time comes and something happens, now you have facts and you can change your, you know, which way the problem goes. So that's how real life works, is you never really have all the information you need, so you make assumptions. But you have to be clear about what your assumptions are. And then you base your results on those assumptions. So whenever I come in and have to brief a general or anyone, I always have to, you know, make sure that they understand what the assumptions are that I'm basing my analysis results on, you know, the result. So with the question, so if I pose you a question, how many golf balls can you fit in a minivan, and that's all the information I give you, I don't give you anything else, how do you solve that?
So you make an assumption. For example, most minivans might be like, I'm just gonna take a guess, most cars are like, what, 6 feet wide? I mean like this, how much? And then you take away the front part, cause that's where you drive, so you take the back, so that may be like 5, maybe? And then you try and guess the diameter or radius of a golf ball, and then you keep on going from there.
Yes.
What about the seat next to you in the front?
No, all good points, right? So when I grade an exam like that, am I gonna get a right or a wrong answer?
There is none.
There is none, right? But what do I grade then? Exactly, I heard it, someone blurred it, that's fine. It's how, the process you went through to do it. So if you list, hey, I made this assumption about the golf ball, it's this size. I made this assumption about the van. My assumption only includes the back of the van. Her assumption includes the seat on the right, right? And that's
I never
fine.
did it.
But as long as you specified, that's my assumption, and I assume that they're about this size. And then, based on that, I made these calculations, and this is my result. That's what I do all the time. So, but I say, this is my assumption, here's my result, and I stand by my result, provided these assumptions are true. Now, what happens when the assumptions are false? I just change the answer, right?
Big fat dude.
Yeah, and which is bad. Politicians, you know, they can never change their minds. That's just the way it works, right? But in reality, when the facts change, you change your mind. That's how it really works, yeah.
Donald Trump went back on to get rid of Obamacare.
Oh, really? Okay. So there's, you know, and what happens is, as you get more information, you realize like, okay, my initial assumptions might have been wrong. That happens, okay? All right, so what else do we want to talk about for that?
Well, I think we can show them an application.
Okay, so, you know, now I'm an operations research analyst for the Army, and that packet that you have just explains what operations research is. So I'm not gonna go over it, but if you wanted to know what operations research is, I also looked at some of the kinds of questions I've had to answer throughout my career. So if you'd like, we could go over a linear programming problem. Linear programming is under the field of optimization. So it's trying to figure out what's the, you know, optimization is either about maximizing something or minimizing. So for instance, throughout your life, you're probably gonna want to, what are some things you might wanna maximize throughout your life?
Money.
Money, right? Wealth,
Happiness.
happiness.
A career that you like.
Okay, your enjoyment in your career, yeah. Okay, back there.
Investments.
Investments, right? Back to wealth, yeah.
Respect.
Respect, these are great things,
Your
yeah.
own like personal health.
Personal health, yeah.
Intelligence?
Intelligence, see, these are great. Okay, we gotta stop, wow. I mean, I love the participation in class, I mean, this is great. So, yeah, there's a lot of things you might wanna maximize, might wanna minimize. Companies, they wanna maximize profit, minimize cost, you know, so, there's a lot of applications to this, and a method was developed after World War II in the Army. It's called linear programming. Programming not in the terms of computer programming, but the government has programs that they have to fund, and the allocation of resources to those programs is what we call programming. So that's a term we use in the government. So one of the problems I have here is, where'd that thing go? Here it is. Okay, this problem. So we have to allocate resources to fund the Army. Okay, the military, to have a strong military force costs a lot of money, okay? It's a lot of money. Plus, we have an all-volunteer force, so it costs even more money. You know, we have no drafts. And believe me, we don't want a draft, okay? So, yeah.
It's still volunteer. You don't exactly have to pay volunteers, so why?
No, you do have to, no, not volunteers terms is like charity. But what we do is, we hire, just like any business.
That.
So by, when I say versus involuntary, where as soon as you graduate high school, you're doing,
Draft.
right, so Israel still has conscription, so everyone in Israel has to go into the army. China's the same way, so everyone in China has to go. There are some exceptions,
I
but
think Sweden
most
does
people
it
do
too.
that.
I think in Sweden you go for 2
Yeah?
years.
Okay, so some places still have conscripted force, But when you have an all-volunteer force, you have people who wanna be there, they're more motivated. You know, the US Army require, you have to have a high school education, and then, you know, the physical standards, you have to pass, physical fitness, level tests and things like that, so, you had a question?
Me?
Yeah?
No.
Oh, okay. So here's a problem that we often have to deal with. So the Army has to protect the nation's citizens and our national interests. So it requires the right composition of forces. So we figure by composition, what we mean there is like what mix of infantry, armor is just tanks, field artillery. So we have to figure out what's that right mix that we need to be able to protect ourselves. And what we want to do here is we have an operational force. So the Army is separated into an institutional force and an operational force. Right now I'm part of the institutional force, which what we do is we make it so that the operational force can fight. So we make sure that they have the personnel, the equipment, the training, the organization, everything that they need to be able to fight. And what we want to do is we want to maximize their combat power. But Congress imposes constraints on us because, you know, it costs money, so they gotta say, okay, this is how big you can be. So next year, the active force has to reduce to 450,000 people, so we're shrinking the Army. And so we have that, and then also Congress signs the check. So they limit us on how much we can pay for the force that we have. So we have an operational force and we have a constraint. So Congress poses a constraint. The number of personnel we have cannot exceed, and the operational force can't exceed 128,000. And then our budget, our annual budget cannot exceed $94 billion. Wouldn't you like 94 billion?
I would love 94 billion.
So then we measure our combat power, and we have a calculation to compute combat power. It's the same thing with, if you play certain video games, you know, certain characters have certain points for offense, defense, survivability, shields, whatever. So it's kind of the same thing. So we want to maximize our combat power. Now we have an armored, BCT is Brigade Combat Team. That's how the Army organizes, by brigade combat teams, a certain organization. So armored is tanks, and then we have infantry. Infantry, those are the muddy boots guys, you know, walking around. So tanks have a higher, you know, an armored battalion has armored brigade has a higher combat power than infantry. And then, but tanks cost a lot more money, so for $5 billion for an armored brigade combat team, $2 billion for infantry. The personnel, it takes more people to maintain tanks. Tanks are very maintenance intensive, so it takes more people than infantry units. So now we're given the cost, the personnel. We have our constraints for personnel and the cost. And what we're trying to figure out is how many of each type of brigade combat team, so how many of the armored and how many of the infantry do we need that will maximize the combat power, but we have to meet those constraints. So, you ready to solve it?
Oh, yeah.
How
Want
much?
to solve it?
No. Are the
Hey, how much
operational
does it
force?
cost per thing?
Well, the operational force cannot exceed 128,000.
Wait, like how many people are in it?
The whole operational force? Well, it may be less than or equal to 128,
Okay.
right, thousand. So that's what we have. So, we go ahead and,
Top one,
I'm not.
top one.
oh,
Now, there you go.
okay. Ah, my computer went off. Okay.
Is it big?
So see if you can follow along with me here. And how much time we got?
We have 42, we're out of here, right?
Yeah.
Yeah.
Okay, so what
Got
we'll
about
do
18
is,
minutes.
okay, so we said we're looking for the right mix of two types of brigade combat teams, right? So we have our variables. So we'll let X be the number of, who's that? Number of,
Oh, you're left-handed?
yep,
Okay.
No,
nah, you don't have to.
Oh.
Oh, okay.
But I'll need your help calculating.
Is that why? I got you. I got a calculator.
Okay, yeah, you got a question?
Yeah, how much does it cost to maintain and like pay people?
To pay people, it depends on what rank you are. So our pay scale, you can actually look this up on the internet, so if you want to find out how much I get paid, you can look it up. It's based on our rank, so I'm a colonel, so I get paid more, and our longevity, how long we've been in the service. So longer, so really higher ranking people tend to be in longer, because it takes a long time to get to the rank. I've been in for 24 years, and I just got promoted to colonel back in May. So, and then to make general, for me, I'd have to serve another 6 years at least to try to make a brigadier general. Okay, so back here, so we got the 2 brigade combat teams, then we have what we call, in linear programming, called an objective function. That's our objective. And what was our objective?
OBJ, 94 billion.
What was it? Yeah, you got it?
Wait, me?
Yeah.
It's pretty much to be able to maximize how much, like,
There you
both
go.
how many people we have, how much it costs, and staying within, like, the constraints of our.
Right, so our constraints. But first, our objective function was to maximize. What were we trying to maximize? Yeah.
Maximize equipment and power.
Combat power.
Combat power.
Combat power. And we had points for our combat power. Remember? It was so an armored had 250 points per brigade combat team. So 250 times the number of armored brigade combat teams. And then infantry had 180 combat power points per infantry. So we're trying to maximize this function. So we have to figure out, okay, what's the maximum? So now we look at our constraints. Constraints, and we had 2 constraints, remember? Someone different, yeah, back there. What's that?
$94 billion.
Maximum for the budget, right? So we have a budget constraint. And that was, had to be less than or equal to
94 billion.
billion. That's right. Okay, and let's see. The armored was 5 billion a year. So 5 billion per year times the number of combat teams. Plus, infantry was how many?
4.
2 billion.
2.
Oh,
So it was 2. So there's our first constraint. It's an inequality. Then we also had personnel, right? That was our second constraint. So, and then we had, okay, how many personnel per brigade combat team? Someone different.
Oh.
Yes, here.
148,000.
That's the constraint. So we can put the constraint 128. That's total for the whole force, right? So how many personnel per brigade combat team for the armor brigade?
But I forget.
Yeah.
I think it was 5,000.
Yes. So it was 5.
Yeah.
5 billion actually.
Wow.
A little bit more, just a little bit. So 5 billion times the number brigade, and then how much for the infantry? Yeah, you remember?
2 billion?
No, that was 4. Oh, wait. Yes, 2 billion. You're right.
And
No.
that 2Y should be a 4.
I'm sorry. You're right. 4,000 personnel. Yes.
Oh, okay.
We're talking about personnel. So 5,000 personnel per brigade, armored brigade combat team, 4 per infantry. So now we have our 2 constraints, but we have 2 more constraints. People often miss these. What? Oh, I thought I heard somebody. Can you have negative brigade combat teams?
No.
No.
No. So X and Y have to be what?
Positive.
Positive. Or can they be 0?
Yeah.
No. It should
Yeah.
not be
Of
0.
course it can.
Right. So to maximum, if we had no constraints, what would be our solution? What would we want to do?
Wait, I forgot.
Which one has more combat power? How would we maximize this if we had no constraints? Yes.
Well, you would just have to infinitely build up your armored force because they have so much more combat power.
There you go. But yeah, so we just stick with armored, right? But there's actually more that goes into this. This is just a simplified problem, yes.
That's just like tactical things. And also, technically, isn't that impossible because like the president is also technically part of the army in a way?
No, he's not. He's not part of the Army. He is our commander-in-chief. One of the things, you'll probably get this later, but the military is under civilian control in the U.S. So he's part of the civilian control of the government. So all the Secretary of the Army, Secretary of the Navy, Secretary of Defense, who's their boss, and then the President, who's his boss. So, but they are not considered part of the military, but they are in charge of the military. So, yeah, when they say he's the commander-in-chief, it does give people the impression that he's part of the military, but he's not. But he is the boss. Okay, and here's another thing, just to put this out, because I have to correct people. Okay, people think that when the president tells us we have to do something, that we have to do it. But there's some exceptions. What's an exception?
Oh, it's like law gets vetoed by the Congress.
Yeah, you're in the right ballpark, right? Yeah.
Isn't there a thing where it's like if you're not like in a war, you can't there's like a cap on how many soldiers you can send out of the country? Or
Well, that's a constraint put on by Congress, yes.
Okay.
That's one of the constraints we're talking about. One more.
Things like the Geneva Convention, like you can't kill innocent civilians that
Yes.
aren't fighting in a war.
So there's caveats to where we can do. So the law of land warfare, that's one, and if anything's unconstitutional. When I took an oath to become an officer, who do you think I swore an oath to? Yeah,
The president,
no,
the people.
no, go, no. I'll give you a hint, it's not a person.
I'll redeem myself.
Back there.
Of the country.
Nope, right there.
Constitution.
Constitution, that's it. So we swear to the Constitution, which includes the first three articles, which cover the President, Congress,
Supreme Court.
and the Supreme Court. So if the President issues us an order, who determines whether or not it's constitutional? Yes,
The Supreme Court.
Supreme Court. And if it's non-constitutional, do I have to follow that order?
No.
No. In fact, I'm obligated not to. If I follow that order, I could be thrown in jail. So I'm obligated not to follow unlawful orders, which a lot of people don't. So when a soldier says, well, I was ordered to do it, do you think that flies in the military?
No.
No, because within the military, we know better. You know, you can't follow an unlawful order. Okay, so the way to solve this, there are methods to solve this. I'm just gonna give you a quick concept of how we solve it. Just doing it graphically,
Oh, cool.
okay? So, now we know.
If I could
so-
just interject one
Yeah.
sec real quick. Guys,
Absolutely.
this will be the lessons right after Christmas. Actually, even before Christmas. We're gonna do exactly this kind of question. In fact, I may crack this out for a do-it one day. Oh, that'd be great.
That seems fun.
Thank you.
You look surprised.
Failed math. Problem question.
Okay, so, first we have to figure out what is the feasible region for solutions. So we have solutions, and our solution is an X and Y. So it's really like a coordinate. We're trying to find out what's the coordinate that's gonna maximize our combat power. So what's the X and Y that we're looking for? So we have to find a feasible solution. So the first thing we know we can tackle is these constraints. X and Y have to be greater than 0. So we know that we're dealing with the first quadrant, right? So right now, we know that this whole quadrant is a feasible solution. Yes,
I was gonna say, can Y be equal to greater than or equal to 0?
yeah,
Oh, cause then I thought the maximum is gonna be 512, RBCs. That's the maximum.
No.
Yeah, maximum.
no. For personnel, you mean?
Yeah, for like the amount of RBCs needed.
No, there's no constraints on the number of X and Ys except whatever these constraints put on it. So that's what we're trying to figure out right now is what are some feasible solutions? What are solutions that could work? So what we have to figure out is, okay, first, let's look at here. And the way to figure this out, just a quick way to graph a line, is just set X equal to 0 and then solve for Y. So if we set X equal to 0 here, that gets eliminated, right? So then we're really just solving 2Y equal to 94. So what do we do to solve for Y? Just blurt it out, it's okay. Divide by 2, right? Divide by 2, so
47.
94 divided by 2,
47.
it's what?
47 billion.
47, I think I wanna use it different.
Well, it's 94 billion divided by 2.
Right,
Yeah, equals 47 billion.
yeah, but these are also in billions.
Oh.
So, yeah, it's kinda messed you up. So this is 94 billion, this was 5 billion, 2 billion. So a lot of times, and I have to admit, we deal with big numbers when we're dealing with the budget. So when we talk about 100 million, you know what people call that?
100?
Dust. Budget dust.
Hmm?
Which is, you know, when I first heard that, I was offended because I'm like, $100,000 of taxpayer dollars, you're calling dust? But that's how the bean counters.
That's honestly a lot
our
of money.
Comptrollers do it. So that was 47. Now we solve for y, or y equals 0. So y equals 0 would be down here. So when y is 0, that goes away. So we have 94 divided by 5 to get x, right? And what was that?
18 point something.
18.8. Okay, so let's say it's here. so 18.8. And then we just draw a line. So that's the line, so if this was an equality, 5x plus 2y, or you can put it y equals mx plus b, right? Put it in that format, and you have your line. But it's an inequality, so we have to figure, okay, to be less than or equal to 94 billion, it's equal to this line or less. So it's actually below this line. So here is, so now we've limited our feasible solution area even smaller, right? But we still have one constraint left. Now we have this one.
Like bougie people, I mean.
So, yeah, so this one is the personnel. So now we want to limit this. So if we set x equal to 0, y would be what? 32?
32.
Okay, so when x is 0, y is 32. Right? And then if y is equal to 0, we divide 128 by what?
25.6.
By 5, and we get
25.6.
25.6. So 25.6. And then we just draw our line. Like that.
Where the red line and the blue line connect, that's where.
Oh, that's.
Right. So now
Ooh.
we're looking at the inequality is everything below the blue line,
So there's that one line.
right? So now the feasible solution is where they both get satisfied. So if we put a dot here, would it solve both?
No.
Would it- No. So it's outside the feasible region. So let's use green.
Yeah.
Okay, so the feasible region that we have now goes from here to here, and then from here down to here. So this is our feasible region. So all of our solutions, so every pair of x and y that we pick will give us a feasible solution. But we're not trying to find a feasible solution, we're trying to find the
The best
Right.
solution.
maximum, or what we call the optimal solution. So we're looking for an optimal solution. For this one, it's a maximum. So one way to do that is just look at the points of the feasible region. So you could plug this one in first, this point. So what pair is that one?
0.32.
0, 32. And you can do this one, which is,
18.80.
and then this one?
14.28.
Close. Close.
I guess.
But how would you solve for that one?
Plus
How do you solve that one? Okay, go.
trial and error.
No. There's a much more efficient method.
Wait, you would find the unit rate, because it says 47 and 32 there, you
Oh.
subtract it, and then you find like where 1 is, like what 1, like the first line would be, and then you go up by there.
Yeah, yeah, that's sort of the trial and error
Okay.
thing, you know, you plugging things in, go ahead.
You can do like 5x plus 2y equals 5x plus 1 or something. You have to
Close.
find where the two lines intersect, so.
Yeah. Yeah, it's called
Simultaneous.
solving simultaneous linear equations. And you'll get that after Christmas, you said?
Right
Or
around.
Thanks, yeah, around Christmas. So,
That's so far away.
what you would do is you use your two constraints that you have, and let's say if I subtracted 94 from both sides, you'd have a negative 94 over here, right? And a 0 over here. Subtract 128 from both sides, you have a negative 128 here and a 0 here. If you put those equal to each other, because they both equal 0 now, then you can solve for x and y, and you can come up with a solution. So this point happens to be 12 and 17.
I was close.
That's why I said you were close. Right, so 12 and 17. Now, what you have left to do is figure out which one's the maximum. So how would you do that?
Hello?
You look at the x and y.
So, right, so now you take this 12,
Yeah.
17, you take all three of these coordinates,
Okay, no,
put them into this function, and whichever one's the greatest, that's the maximum. Which one do you think, just by guessing, which one do you think will produce the maximum? Yeah. 12 and 17, right. 12 and 17 actually comes out to 6,060 combat power points, which is greater than the other two. So that's how you solve a linear programming problem graphically. Okay? So now, anyone have any questions of me before you gotta get out of here? Anything, go ahead.
What is it like to be in the Army? Just,
I enjoyed it. There are times when you're in training, so a lot of times in the movies, you'll see like people in basic training, and that's like
Guidance,
under
Caroline.
extreme circumstances. Most of the time, it's just like a regular job. I kiss my wife and kids goodbye in the morning, I go off to do my job, I come back in the evening, and I'm there. Except every once in a while, I have to go off to a foreign country, So, and that does suck. I'd rather not do that. Yeah.
When you were in Kosovo, I know it's NATO overall, but who were what nations do you know were the commanders from the operation?
I'm sorry, what?
When you were in Kosovo, it was NATO, but what commanders were what nations were the commanders from, like the entire operation?
Yeah, so they divided Kosovo up into sectors, and each sector had a commander. So I was in the U.S. sector, so I reported to a U.S. general, and but I was also part of the Joint Implementation Commission, so I also had another boss who was a French general. So I kind of had two bosses when I was there. So I worked for the French, and then I worked very closely with the British in Kosovo. Yeah.
Okay, so I got that.
Okay, next.
Did the general speak fence, or to speak English, or do you have to like learn fence to like communicate the fence and learn Kosovo?
How would I communicate?
Yeah.
I had 3 Albanian interpreters assigned to me, so they worked for me, and I had 1 Serbian interpreter who worked for me. So I would work through them because I didn't know the language. I picked it up while I was there, but only just so much. But that's usually how we do it. Now, our special forces guys they're assigned by region. So our special forces are the ones they get cultural training, they get language training, they immerse themselves in a country, they become friends with the people, the government and all that. So that's what our special forces do, the Green Berets.
Did you ever work with the CIA and
Yes. Yeah. The CIA, not so much the FBI.
Hasta la vista,
Thank
Thank you.
Thank you.
You're welcome.
Stephanie Cando tonight.
Bye.
Stephanie Cando
So
tonight.
is this how you see the world? Like you see numbers?
Oh my gosh.
Not so much numbers, but I see it as
Thank
a big puzzle, a game.
I
In
love
fact,
that.
It's a
a big,
video game. We haven't run out of lives yet.
bye. Yeah,
It's like a game where it's ultra hardcore mode.
game theory is actually a branch of mathematics. So,
Oh, really?
Like Call of Duty, just more
You
math.
should, if you ever had the opportunity, you should see Mr. Cristofaro with his, he's quite the illusionist.
yeah.
Yeah.
All right, maybe right at the end of 8th period.
Alright, thanks.
All right,
Okay.
see you later,
Have a
guys.
nice day.
Good, take care. Yeah. Did that take video too?